Hi, this is Lori, and this is my homework for Paul McWhorter's AI on the Edge class. This covers the homework that was assigned in Lesson 8 and covered, I believe, in Lesson 9. So we're starting to use a text-to-speech engine called Piper with our project. And I didn't know anything about Piper, and I like to know a little bit about something when I start using it. So I did a little research, and I haven't done much yet with it, but I I found the documentation for it in the Python standard documentation, and so you can read just a little bit about it. I think it's interesting. So it's a high performance local, which makes sense because we're trying to do AI on the edge, neural text to speech engine. And right away in the second sentence, it already talks about a couple things that I didn't know anything about either. So it leverages this eSpeak-NG for phonymization, if I said that right, and this ONNX runtime for efficient neural network interface. So those are two more things I don't know anything about, and so I did click on them a little bit, but I definitely will spend some more time learning what they are and how they're leveraged in making this model work for us. The other thing I found as I started Googling to figure out what Piper was that there are, we know there's from the lesson, there's a bunch of voices that is built into what Sunfounder provided for us. Those are the standard Piper voices. If you go down in here and read, you'll see the available voices. So we've got the ones that are considered, I guess, the standard for Piper, but you can see that you can train new voices. And in fact, I found several GitHub sites with people that had different voices that you could use with Piper. I quickly tried to just download a couple and put them into the proper folder, but Sunfounder has hard-coded some of that in, so it doesn't just look into the folder and see all the voices that are there. It has obviously the dictionary that we used in the class, and so I'll probably have to do some editing to those files to make other voices available. And some of the other voices were very fun, so I'm definitely going to spend a little time on that too. But I'm a little behind in the homework, so I need to get caught up and not get lost in the very first lesson, which often happens to me with Paul's courses. I get behind, and then I've spent so many hours on some other, learning the details of something, and I'm like, 20 episodes behind. Okay, so enough talking, but I just thought for those who maybe were curious, you can definitely learn some more about Piper, and there's obviously a lot we can do with it. All right, our homework for lesson 8 was to combine our RGB LED dimming homework from lesson 6 with the text-to-speech code and have the project tell us the level of brightness as we move our potentiometer. And from the demo that Paul gave us when he assigned the homework, you could kind of tell that he had about 10 levels of brightness. So I knew we needed multiple levels, and he didn't want us to just say what was the percent brightness that we were putting into it. He wanted us to say something like brightness is level 1 or brightness is level 2. So that was the goal as far as I could tell from the assignment. So let's go through what I put together. So you can see what I imported, and I also imported the median function from the statistics library, because if you saw my homework from lesson 6, I am taking 3 readings and taking the median of those 3, so the middle value, to reduce the amount of noise that is in the potentiometer readings. It helps a little. I'm not sure it's really worth it, but that's how I had it, so I'm not going to change it. And the rest of this is just some setup. So a lot of times I go the opposite direction because Macs and PCs and Raspberry Pis, the scroll on the mouse goes in the opposite direction. So just give me a little bit of grace here, because sometimes it takes me a while to get it to scroll in the direction I want. And there's a little delay because I'm using the Raspberry Pi Connect as well on my Mac to capture this. So you can see just setting everything up the way we've learned. Here's where I set the number of readings I'm going to use to reduce the noise in the potentiometer. I have a couple of delays in here. There's a delay to get the 3 readings, and then I have a overall loop delay of 1/4 of a second, but that makes it a little less responsive, but it takes a little while for the project to tell me what level of brightness is. So I don't know whether you want to hammer it too hard. So, I mean, I guess it's a fine line figuring out how fast you want that loop to run. The other thing is, and I did think of this before I watched the solution by Paul, that I didn't want the thing to talk at me constantly. So I felt proud of that. So I set the previous message to just blank. So my message is a string, and that's what I'm checking to see if the message has changed or not. Now, I have a little function here that I'll come back to, but it's how I decide what level of brightness to send as the message. So we'll come back to that. Might be better just to start off with the program and then look at where that fits in. So this is just the code I used to get the 3 readings and to get the median of that. And that was in my previous homework. And then here's the code that I used to put reading on a 0 to 100 scale. So take that median reading and put it on a 0 to 100 scale. So you could just put this in to set the brightness, but then that makes it linear, right? So I wanted to use the nonlinear dimming equation that I had. But I have this reading 100 because I'm going to divide up the 0 to 100 scale evenly and the reading scale to decide, should I say level 1 brightness, level 2 brightness, level 3 brightness. But the percent that I'm putting into the RGB LED is going to be based on the nonlinear equation. And I didn't want to use that to decide, is it level 1 or 2? Because, the percent range for the first couple of levels is pretty narrow. So that's what I have, why I have 2 variables, as you'll see. And then here comes the nonlinear dimming equation. I did discuss this in my last homework, so I won't spend a lot of time, but you can see I'm using sort of an exponential value where I'm taking that reading and raising it to the power of the reading over 100, so a decimal value. And then I'm calling that function if we're in here. So if we're in here, it's off. If we're in here, if we're over 4,000, it's just going to be on, and the message is either going to be off or full brightness. But if it's in between, then we're going to use our nonlinear dimming equation, and we're going to create the message from that function. So now I'll just scroll back to it ever so carefully here. And it's just a bunch of if-elifs. I played around with the levels, and that's why I left it as one big if statement. I happen to like if, elif, and else statements, unlike Paul. I think you can mess up even if you just use regular if statements. I know that's his frustration with them, but I mean, you can mess those up too and leave out a case and have nothing happen. So I think it's just as dangerous, honestly. But you can see here's where I set up the other levels. So there's off, fully on, and then there's level 1 through 9. So I guess I've got 11 levels of brightness that can be spoken. So we'll go back now. So that's where this gets called. And then we set the brightness using the nonlinear dimming equation, or either a 0 or 100 if we want it just to be fully on or fully off. And then we're going to create the final message. So I want the Piper to say something a little more than just level 1 or off or on. So it's going to say brightness setting is, and it's going to give the message that was determined from that if, elif statements. And then we're going to just check and see, has the message changed? Did that message that gets put into this F string, did that change from the last time? If it did, go ahead and say it. Otherwise, don't change or say anything else. But we're still updating the LED. So if we just move it a hair, although I find that very hard to do, if we move it just a little bit, but we don't move out of the range of a particular level, then it's not going to re-say it, but it might change the LED brightness level. And then I had this print statement here to debug and see how things were working. That's probably not necessary, but and it's a little crazy. You can actually see the program is running. I'll come down here. If I can get into the right spot. Yeah, there we go. down here you can see it's actually running right now, and it's just off, and it's not talking because the message hasn't changed. So, all right. And so then it's important that we need to reset the message, previous message to the current message to have that check work. And then I use the try and accept so we can make sure the LED gets turned off. So that's how I handled it. All right, so let's demo this. I'm gonna try to switch to using a separate mic closer to the project so that we can hear it better. So I'm using my AirPods to record my voice. I'll need to switch those off and turn on the other mic so that we can hear the project a little bit better. Okay, so hopefully this is working, and we're gonna turn it up.
Brightness setting is level 1. Brightness setting is level 2. Brightness setting is level 3. Brightness setting is level 4. Brightness setting is level 5.
Okay, so we've got halfway up. Let's just go all the way to the top and turn it fully on.
Brightness setting is level 8. Brightness setting is full brightness.
Yeah, so it caught one in between. So it works pretty well. We'll turn it all the way down.
Brightness setting is level 8. Brightness setting is off.
Okay, so that's my homework. Thank you, Paul, for the great lesson, and thank you for watching.